Today we'll be looking at SEER for manufacturing and SEER 3D. I'll give you a demonstration on all of the products and hopefully give you an insight into the capabilities and the speed and accuracy that you can achieve whilst using Gallerith's SEER for 3D and SEER for MFG. Please feel free to download our vision and value executive overview at gallerith.com. If you need any training and support, please contact support@gallerith.com. For sales and product inquiries within the Americas, please contact Chris Hutchings. For sales and inquiries outside of the Americas, please contact David Sims. And for any further information, please contact our customer engagement specialist, Cassidy. So what are we going to look at today? So today we'll be looking at SEER for manufacturing. The SEER for manufacturing is our costing engine, whether you're using the 3D solutions, whether you're using a traditional 2D manufacturing process, whether it's machining, composites, fabrication, looms, harnesses, fiber optics, moldings, castings, forgings, and a wide variety of other processes can be done in SEER for manufacturing. When it comes to SEER for 3D, we have additive manufacturing, machining, sheet metal fabrication, castings, forgings, injection moldings. There's rotational moldings and other ones in there as well, which we'll look at. And of course, assembly. So let's have a look at what we're going to look at today and what we have. So let's start with a nice simple sheet metal. So this is the interface for SEER 3D. What we have to do, we import a part, which we have done, and we have the ability then to nominate its process. Now, this has been nominated as sheet metal, so it could be machining, additive manufacture, composites, mold cast forgings, and these two at the bottom, fasteners and purchase parts, become available when we're doing assemblies as well. So this is the part. We'll leave it at sheet metal. We'll go to our cost inputs, and over here you'll see first thing we need to do is select a manufacturing environment. The manufacturing environments are rules that govern the control of the process, the capabilities, the efficiencies, defaults for things like tooling and material type and other things, including rates, if you want to set them at the beginning. So once that's set, you then confirm the material choice. Now, this one's brought in aluminium alloys by default, which we'll leave. Bounding box is the yellow line around the outside, and you can control that and look at it in different ways if you have orientation issues as well. How are we going to bend it? So this environment is assumed we're going to use brake forming, aluminium brake forming, and the other options available include many of the big processes: draw rubber, progressive dies, stretch forming, spinning, drawing, conventional machines such as guillotines, bolster presses, and so on. So we'll leave it at wherever it was, brake form. And then at the bottom, all we have here is some information relating to the part's geometry, its weight, its volume, surface area, based upon step file and based upon the material type and its density. We have a shape complexity that's already calculated for us, though this shape complexity is based upon the features. So the model identifies each of the features, and you can see them here. You can highlight them and see what they are, and all of them are ranked in complexity. So these may be a 2, these may be a 3, this may be a 4, but whatever they are, they add up and are summed at the bottom, and that value is what's used here to control the shape complexity. You have control of that within your manufacturing environment. You can change the ranking. So if you want to make this a simpler part, you just descale that part and so on. The process options in this one here. So we're going to do brake pressing already. So this one's going to be NC drill and route. We're going to do some iodine, anodized, epoxy prime, and finishing heat treat. So this is, I'll turn that one off. This is available. So if you say I don't want to NC route it, I want to use a laser beam, you can just swap them over, as easy as that. We'll leave it at the default. We looked at the features. It does do DFM analysis. We can run DFM if there's anything that may be improved. That's a key feature. So in this case, there was nothing. So we'll click it again on another part. But in principle, we just click on estimate and off it will go. It'll do a calculation. And what's going on at the moment, it's taking all the information from the environment. It's taking the information from the knowledge bases, which are also part of the environment, which help set up SEER MFG to do an estimate for this part. It'll have everything there, the material, its bounding box, its sizes, giving us a material costs. It'll have all the process steps that we need. And then once that's finished, it will end up with a nice, simple estimate for this part. There we go. So this is the part. Aluminium brake form, that's just the name of the environment. These are the operational sequences. So this is using the process called Pro Sheet Metal. So that's this one here. That's part of the version that was created by the partners of the F-35 Lightning. Click on OK, I won't change anything. So on the General tab, we have information relating to the production quantity, setup amortization, tooling quantity, labor rates, product experience and optimization. So how good are the people? And you notice we have 3 inputs. Now these 3 inputs help capture uncertainty. So in reality, a production shop, because we're not rating the individual, we're rating that shop we anticipate will be produced in. And what we have here is the least, the likely, and the most. So you can see in this case that we think they're all going to be high, and you can read the help. So their experience, 3 years experience of this type of process, and that's what this one has been set. This can be used as a kind of a calibrator. So obviously the better you make the people, the lower the cost will be. And once you're into it, you'll know that high works for you, high, very high works for you, and so on. And product classification is where we control whether this is going to be an industrial part, a commercial part, something that's going to sit on an aircraft. So there's a wide variety of different process groups, as well as different application environments. So that's that set. We've done 5 prior units before, so that's bringing us down on the learning curve. And then the main work is done here. So this is the information brought in from the environment. We're looking at the part length, part width, part area, and part thickness. The part family is brackets and clips, and that's just pointing the tool towards what tooling to select for this possible part. It's made from aluminium alloys. The material is editable. You can add your own materials to SEER for manufacturing. We don't know what you buy. We don't know how much you buy. So you can put your own prices in to make it even more accurate for yourselves. Information relating to any reclaim factors, if you're going to use that. And then the operations themselves. So this particular process is very parametrically driven. So yes, we're going to do some preform, which is an NC driven route. So always say yes. Brake form, we're doing a brake form operation here, nothing else. And then we come back into the anodize and epoxy prime, which we have selected in the process steps. And that's it. That is that part done. You can have a look at outputs. So we can right click, choose active charts. You have a wide range of charts. You simply find the ones you want to look at. When you're ready, happy, we'll look at, we could do lots. We could look at, they're all fixed and done. Learning curve analysis is another part of it, and so on. So we'll click on OK, and these will appear in the list. So this is the learning curve. So you'll see, because I've only done one, I'll change that now to 100. Just double click, click on OK. And now this chart now is going to show how that part is coming down in cost and time as it comes down all of the units right the way through to the 100. So you can see your T100, you can see your T1. And so if you want to do price breaks, for example, they want to buy 20, you can read across the line and hey presto, that's the value you need to charge, plus all your uplifts. So the quick estimate is special in the way that you can right click, quick estimate options, and you can choose things to add to that list if you wish to. That will just appear in the list, and you can go options, save configuration, so that's fingerprinted every time you start a new program. It's also special in the respect that we can set a reference. Click on OK. You can set up to 5 references. And what we do then, we can come here and say, what happens if we put better people on it? So we've got a range of capabilities. We've got some superstars. We've got some highly skilled people. And maybe we have some semi-skilled or apprentices that are not quite up to speed yet. Click on OK. And you can see that's had an increase in decrease in time. It's dropped 22%. So it's a good decision to put better people on it. And again, these two work together for your calibration when you're setting this up at the beginning. You can turn tooling on here, double click on yes. And here we are in SEER for manufacturing. That was the recommended tools for this. I'll just clear this reference. Inspection rework, you can do non-destructive testing, which would be part of your environment. We'll just click on Y for yes, and then double click here. It's a growing list of operations, whether you want to do CMM, whether you want to do pulse echo, harnesses, Dipnico, glow penetrance, inspections, and so on, can all be done there. Simply select the one you want, tell it whether you want to do it by the area or by the number of points you're going to inspect, and that will then give you a cost for inspection. Additional items are basically empty. In this case, there was nothing done in it, but this is a catch-all for Gallerith. It allows us to put other things into the model which you didn't have in there. And this comes in from SEER 3D, the local parameters, and all of the things here can be done, added up, and brought in. So that's SEER for manufacturing in its native form. This is where we could do that exact same part by starting a new project, entering a sheet metal operation, tell it how they're going to make, and so on and so forth. If we pop back to 3D and look at that same part, one of the other things in the new features, we have PMI data. So if there was any information stored, which there is in this case, you can see the tolerancing that came in with this from the file when it was created. And SEER's beginning to work on these values, adjusting the estimate according to the feature, its complexity, its tolerance, and so on. So other processes available to it. So we could do a casting. So in this case, we can go over here, go back to the structure, select the part, go to the cost inputs. So in this case, we're going to choose molding, casting, and forging. And as I said earlier, there are other processes available to you. That one there. So we got these environments for us to choose from. And then the processes, we've got injection molding, rotational molding, thermoform molding, compression molding, the castings, the forgings, powder metal, and isostatic pressing are the options available for you here. We'll just call it a sand casting. We're going to make 1,000 batches of 100. And that's all we have to do. Click on estimate, and again, that will go off and create us an estimate in SEER for manufacturing. So here we go. That estimate's been done. So you see different work elements now. We're back in SEER for manufacturing. We have a sand casting. And again, we have our general tab telling us our quantities, labor rates, capabilities, people, product classification, the process specific. So the process itself we selected was sand casting. Is brought in information relating to the envelope size, runner systems, casting weights, and so on. So it's 62 kilograms. And other information relating to the process. We got our cost, our time, got our detailed analysis report, cost of 1,000 units, cost per unit, setup, direct minutes, inspection minutes, and rework, no purchase parts, and so on. So that's how easy it is to use SEER for manufacturing. If you want to add an operation, it's very easy. You can insert a work element. We can say I want to do a little bit of machining. So we're now using it in its native form. By simple tooling holes, machining. I can copy common parameters. I'll bring in the quantities, etc. It makes it nice and easy. So that's brought in everything here which we wanted. Process specific then. We have aluminium stock, which we want. No cost, because that's already catered for in there. Operations. So this is the list of available operations within machining. We've got all the milling operations, turning operations, grinding, EDM, pocketing, surface skimming, thread cutting, thread milling, lapping, honing, wire winding, etc. We'll do a simple drill hole, tooling holes. Two of them are going to be 8 millimeters deep, 8 millimeters diameter. Click on OK. That's now gone into the list. So we'll have a time for that added on to the original process that was done by SEER 3D. So that's how easy it is to add operations. Now, if I insert a work element here, now we're in native MFG, you can see we've just added a machining. We could add fabrication. This is electrical assembly. So this is your cables, harnesses, looms, fiber optic cables. Assembly is mechanical assembly, bringing things together, ready for putting together. We can do riveting, we can do welding in there as well. Molding, casting, forging, we had a look at that. This is the sand casting. PCB, we'll take a look at separately in a minute. Finish and heat treatment, composites. The ones that say Pro are the F-35 Lightning. Extensive coverage for assembly, composite operations, curing, trimming, paste bonding, E-beam assembly, 3D reinforcement. The sheet metal version we saw earlier with the aero, and super plastic forming, diffusion bonding, additional items, purchase parts, detailed composites, tube weld fab for fuel pipes, etc., and additive manufacturing. So we have a very extensive list that's available to you, more so than we have in the 3D options at the moment. So you can come in here and you can pick up your PDF, your drawing, and say, right, I've got to do a harness, proceed, do it in a traditional estimating way. So we come back again. So it does assemblies, complex assemblies. This is a complex part, looking at all the bits in it. And what I wanted to do is just show you, you select each of the parts, you tell it what you want to do to it. And then we come to this one. We can look at complex 3D assembly. So this is the part that it created from that complex assembly, all of the operations, all of the parts, all grouped together. Now, some of this was manually intervened. I had to add some final clearance operations manually. These are all steps to get it inspected, approved, etc. But as you can see, it adds an awful lot of detail very, very quickly if you want to do complex assemblies. I'll just take you through the process of assemblies. So this is a nice simple assembly, something we can do now. So the first thing we do is we select this line here, say it's an assembly, it's a brake fitting assembly. We're making 100 of them. We're not doing anything with the mounting box. Finishing heat treatment's on, and there we go. So the first thing we do, select the first item, and it's a sheet metal part. So we can look at the features, that's the bends, etc. Process options, so it's CNC laser beam cutting. We're going to cut it out. On this one, it's going to tell us we're going to do some brake forming. Coming back down through the process, any treatments, passivate, polyurethane paint, and zinc chromate primer. The next one are just purchase parts. So we just select fasteners as the process group, select them from the list. You can add all your own fasteners into the model as well. That's the same part. This is one of the machined items. Now, what I'll do here is I'll just show you the process. Again, we select the manufacturing environment. Quantity has been carried through from the top level. We're making it from raw stock, carbon steel. And on this one here, we look at the roughing operation. So it's going to cut away the raw stock externally. which is basically telling us to cut this profile out and not mill away this great big mass of waste material. So we're just going to cut out the periphery. We're doing some volume rough milling and some detailed rough milling. Surface finish operations. So this is the machining ops or the finishing ops. And these can be selected. You could look at that one and you can say, well, this is going to be a function of the cutter radius. So you could turn that one off if you wanted to. I'll leave them on. And for each surface, you can analyze it, you can measure it, you can do all sorts of things with it. Close that one. And then finally, we look at the holes and we can identify the holes and we can say, well, this one's going to be tapped, it's going to be a through hole. It's not actually, it's going to be a through hole for the bolts. So we'll leave that as is. We have another part here, which is part of the frame itself. So if we go back, you can see that is this part here. And that's that. So we'll go to that one. Sorry, that one. And this one is going to be the same, the rough operations, finish operations. But this time we have tapped holes here. So we'll select it and then come to this one. And it's tapped already. So that's good. These are through holes at the bottom. We don't need to do anything with them. We have top cap. There's nothing different or difficult about that. Again, select the knowledge base, fill up the quantity, check the materials right. Roughing operations will be covered. Surface operations, there's going to be no holes to worry about. It's a through hole. Then we have another sheet metal part. If we just go back to and look at what it looks like. So that's that one. So that's our part. And again, simple brake press fitting, just 2 straight bends, nothing much to worry about. Our features are identified here. So we've got these 2 bends and the cutouts. And finally, you have 2 purchased parts, 2 pins, 2 fasteners, and that's all there is to it. So we have that done. And again, we can click on this one. I didn't show you this, but this is going to show us the fit up operations, identifying all of the parts, identifying the fasteners, identifying the mating surfaces, and there's no hand drilling, so that's going to be blank. So that's all to do with the assembly. Click on estimate, and we'll go off and we'll do an estimate for this one. So there we go. That's done the estimate. So we have all of the parts that have been done. We have our brake, number 13, which is a sheet metal operation. That's doing all of the parts here, as we've seen before. There are some process operations afterwards there in so this is a finish and heat treatment operation. As you can see, you're going to have to do some low carbon still, preform operations. Here's the finishing, solvent cleaning and electroplating on that one there. Do the same on this part. This one is the same. Some more forming operations. And then finally at the top, we have the fit up, which is bringing everything together into the assembly. If we look at the parts, we have our 3 machine parts, 2 details, which are the fabricated parts. We then have our fasteners over here. So this is our nuts, bolts, and washers. We're bringing them in, 2 of them, 2 hinge pins, and then again, any final painting. And this is the completed assembly, as you can see it. So that's how the 3D assembly works. So now we're back in SEER for manufacturing. I just wanted to show you a commercial part. This is a roof box assembly. So we've got some injection molding operations here. We're doing injection molding. That's the top and bottom shell. We got some purchase parts, rivets, gas springs, and so on. Something else here fabricated, something there machined. So all of those parts come together to produce us a roof box assembly. Here's all the parts being brought together in a conventional assembly operation. But what I wanted to show you now is getting information out. So we have all of our standard reports and charts and everything else associated with the model. But we also have a very powerful feature called flexible export. So I'll go import export, flexible export. find one that's suitable. We'll go to Outsum, which is a very popular one, load it. And what that's done is loaded all of these features that it's going to extract. Options, it's going to take it to the clipboard for the entire project by columns, including rows, etc. And we'll export it, put it on the clipboard. We can go to Excel and then paste. And then you can see we have the process type, the part number, and all of the labor cost in minutes. And you can control these. You can take out exactly what you want to do for your reporting or further detailed analysis. So that's something important for you to see. One of the other ones, which is a new feature, I come back. This is a PCB done 3 ways. So just wanted to show you the level of detail that we go down to for a PCB. So we start off with the board fabrication, length, width, area. Then we go through this is board materials and the processes in creating that board. So that's board and all of its printing and inspection and gold plating and other things. And we have the assembly of that board, putting the things on, the kitting, inspection, screen printing, pick and place, all the way down through washing, and then finally the bill of materials itself. So that's just all of that done in a single operation. This is doing the same thing by ops. So this is just doing the board testing. This is doing some inspection. This is doing surface mount inspection, board testing, soldering. So it's just giving you that further granularity. And this is taking it one step further again by putting in an individual operation for everything, which then allows you to put in individual labor rates for each one as well. So that's PCBs in SEER for manufacturing. And I think that's probably all we need to see. Another one here, looking at all the parts, process specific. So if we come here, energy and CO2, that's a new feature within SEER as well. So we can look at some of these processes here. You can see information relating to it. We then have the ability to reclaim and get benefits. So you can get energy credits back. If you're looking to reduce it, we can say we're going to recycle the part, and that will give us a cost credit at the bottom here when we come to the analysis. So we've done some potential credit is this amount here, which is halved our emissions. So if you're going to go green, this will help you get there by going through the different processes, choosing the optimum process that gives the lowest output. It also does transportation at the top as well, so you can add your transport. So this isn't the cost of the transport, this is the cost in energy to take this diesel truck or the ship all the way around to transport this from supplier to depot for final use. So that's the final feature within SEER for manufacturing. So we've looked at the 3D assembly and so on. The only one we haven't covered is we'll take that part there. We'll come to our cost inputs. We'll come to this part. We'll go to here. We'll go to general. We'll say it's going to be now made of additive manufacturing. Select one of the processes. Tell it what we're going to make it through. Carbon steel. We can add materials if we want to, but we can say we're going to have 5% of that and 95% of that one. Click on OK. Click on estimate, and that will take us into SEER for manufacturing. And finally, you'll see the additive manufacturing capability being estimated. So here we are. The additive manufacturer has run. This is our process steps. This time we have additive here. So we've done the assembly again, but this time we've corrected it to be additive manufacturer. And just to show you, these are typical inputs. There's our two materials, their percentages, information relating to all the characteristics of the build, any support structure, and so on will be covered in here. and that is additive in SEER for manufacturing. So once again, thank you very much. We've looked at everything here. We've had a quick look through the processes. We've seen SEER for manufacturing multiple times because that's the costing engine behind 3D. So thank you very much for your time. Please visit the website. Please contact either Chris, David, or Cassidy. They will look after you. And if you want any training or support, please email us and we can sort that out with you as well. Or please talk to Cassidy. We will be pleased to help you. So thank you very much. And I look forward to the next demonstration.